So we actually find 8.4 sum of infinite geometric series. So what's that means? Sum means you're adding stuff together. Infinite means it goes on forever. Geometrically, remember, it means that there's a pattern, and the pattern is I keep multiplying by the same number over and over and over again. And of course, series again is just I'm adding all the terms of my pattern. Okay? So for numbers 1 and 2, they really just kind of introduce me to this idea. And so they say, well, these are infinite geometric series. As they multiply by something, and they do go on forever. They say, well, what are our partial sums? And by that, they just mean, well, what if we add, what would we have just the first term? And then what if we add the first 2 terms together, and then the first 3 terms, and the first 4 terms, and then the first 5 terms, and then to see what are they approaching. Okay, so let's see if we can do that. I could, on my calculator, I might do the first one. So 1 divided by 3 divided by 3 is what? Number, I'm going to do any decimal. So let me see that. Okay, so that's 1 divided by 3. What if I do 1 divided by 3, the first term, plus the second term, 1 divided by 6. Okay, I'm at 0.5. What if I take that number? Okay, well, it'd be easier to see if I take that. And then now I'm adding the third term as well, which is 1 divided by 12. 12. I'm at 0.58. Repeating. What if I add another term in there? Okay, I'm at 0.65. Notice that each number I add is getting smaller and smaller and smaller. And so the idea is that because my numbers that I'm adding keeps getting smaller and smaller and smaller, even though I'm going to infinity, there's actually a certain number that this will all add up to, even though I'm adding an infinite amount of numbers, because ultimately my numbers are going to get so incredibly small, they're not going to make a difference. 1 divided by 4. Okay, so I've been typing these numbers, and we got to the end. We typed in eventually all 5 numbers. What does it appear that we are getting closer and closer and closer to? Basically, just take a guess. What does it look like? If we kept going forever, what do you think they're going to all add up to? So I take a guess, and we'll say maybe 0.7, or maybe that's too high. Maybe they're going to add to make 0.65, or maybe 0.7. Too low. Maybe you think they're going to add to make 0.8. Whatever you think, hey, make a guess. And then we're going to figure out what they actually add to me. Right? And so, let me switch over to my video. I'm going to work this problem out. Oh, the video. All right. So I'm going to write out our problem. It is 1/3 plus 1/6 plus 1/12 plus that's enough information there. You'll see above here I wrote our formula that we are going to use. So let's see what this actually ends up adding to B. Now let's look at our formula. It says A, and I really could have said that that's A sub 1. That's A sub 1, and there's my R. Okay, well, A sub 1 for our problem is 1/3. And then my R, well, what do I keep adding over and over and over? Well, multiplying. 3 times what is 6? And then 6 times what is 12? Well, I keep multiplying the bottoms by 2. So my R is 1/2. So I'm going to take these and plug them into this formula. So I have 1/3 on top, 1 minus 1/2 on the bottom. And I can type this into my calculator just the way it looks. Over here, I don't know if you can see what I'm typing or not. Alpha y equals 1. So I'm going to put a fraction inside of a fraction. So 1/3. And the bottom, put another fraction. 1, 2, sort of that. Minus, so there we go. And I end up with a fraction answer. My fraction answer is 2/3, or if I'm doing this as a decimal, 2 divided by 3 is 0. We'll say 66 repeating, or I'll just round her. 2 decimal places and say 2.67. Okay. So how am I able to add up an infinite amount of numbers and not only come up with a number, but come up with a pretty small number? Well, it's because my R was less than 1. So because my R is less than 1, my numbers here keep getting smaller and smaller, or rather they keep approaching 0. So as I go forever, these numbers are getting closer and closer and closer to 0. If this R value was greater than 1, say it was 2 or 3/2, then I could not do this. This rule right here would not work. It only works if R is less than 1. Okay. Let's try some other ones. I'll flip that. Share screen again. What about number 3? Number 3 that I have summation. N equals 1, infinity on the top, 7, 1/4, n³ minus 1. Of course, even that was number 3. And then below there, I'll put number 5. And that's 3 plus 9/5 plus 27. 5. Okay. So we'll work out those. One type of formula. Let's start with this. Notice it's already in the form as this. So that means that what's in parentheses is my R, and that number in front at 7 is my A sub 1. So I just need to plug into my formula. My formula says I take the A sub 1 over 1 minus my R, which is 1/4. Pull the calculator out. Okay. Alpha y equals, I got 7 on top. In the bottom, I have 1 minus, and then another fraction, 1/4. So if I plug that in, I end up with 28/3. And 28 divided by 3 is approximately 9.33. And what if they don't look like that, though? What if they look like this? Well, I can still figure out. The A sub 1 is pretty simple to figure out. There's A sub 1 right there. All right, what about my R? Well, what do I multiply this by to get this? It might be easier if I think of this as 3/1. Well, let's look at the top. 3 times what is 9? Well, 3 times 3 is 9. And 1 times what is 5? Well, 1 times 5 is 5. Well, does that work for the next one? 3 times 9 is 27. 5 times 5 is 25. Good. 3 times 27 is 81. 5 times 25, 125. So this works for my R. And so now I can plug into the formula. A sub 1 1 minus r. Turn the calculator out and say, okay, alpha y equals fraction 3 over 1 minus another fraction 3 divided 3 over alpha. That gives me 15 over 2, and that should be 7.5. There we go. Now if I move back, there's one last type of problem. It says write the repeating decimal as a fraction in simplest form. There are various ways they want me to use to show you how to do this. So right here. So numbers 9, 10, and 11 are the ones we're looking at. They say write them as a fraction in repeating form. So to do this, stop that. We'll pull my calculator up. I'm going to type it in the calculator just the way it looks. So the first one, 0.18181. Okay, type it in a bunch of times. I'm going to hit the math button, and it says arrow frac and arrow dec. All right, that stands for fraction and decimal. It basically says, which one do you want your answer as? Well, I want my answer as a fraction. So I'm going to hit enter. I'm telling it, take that decimal and turn it into a fraction for me. I hit enter, and it gives me 2 over 11. So number 9, 2/11 is decimal as a fraction. And yeah, there it is.